You guys already know the four elements: fire, water, air and earth. But in the 19th century, two guys named Dmitri and Lothar came along and claimed, nope, there are many more elements, not just these four. So they created a table with other elements, which was further developed until it became the periodic table that exists today. Now we'll look into how exactly this table is built and how it works. Let's go step by step. First, let's look at what a cell represents in the periodic table. Each cell represents one element. Each element has an abbreviation, so you don't have to say the whole name. So, for example, carbon is abbreviated as C. Its full name in Latin is carbonium. Or you take L for lumus. Ah crap, that was Harry Potter. On the upper left corner of the cell is the atomic number. All elements are arranged in order by the atomic number from top left to bottom right. The lowest number is 1 for hydrogen and the highest is 118 for organocin. But the actual purpose of the atomic number is to show the number of protons and also electrons that exist in the element. Remember, protons are positively charged and electrons are negatively charged and elements are neutral. So there has to be the same amount of both. If you go through the rows from top down and left to right like you're reading a book, every next element in the periodic table has an additional proton and electron. That is the most crucial difference between elements. The only difference between oxygen, which is vital for our survival, and nitrogen is that oxygen has an additional proton and electron. That's badass! So hydrogen has 1 proton and 1 electron, whereas carbon has 6 protons and 6 electrons. Alright? In addition to the atomic number, there also is the atomic mass, or the mass number of elements. This is usually depicted below the element symbol, but can also occasionally be placed above it, like in this case. The mass number stands for two things. First of all, the atomic mass is specified with U, which is a tiny little fraction of a gram. A carbon atom, for example, weighs 12 U. Second, the molar mass is specified with M. This indicates how many grams a mole of an element weighs. For carbon, it is 12 grams per mole. But what the hell is a mole? A mole consists of 6.022 times 10 to the power 23rd particles. This could involve atoms, molecules, or whatever. This means for carbon, 6.022 times 10 to the 23rd particles carbon weighs 12 grams. This defines the molar mass. Conveniently, 1 mole protons or neutrons weighs about 1 gram, whereas 1 proton or 1 neutron weighs exactly 1 U. With the mass number and atomic number, we can determine the amount of neutrons in the nucleus. To do this, we simply subtract the atomic number from the mass number. As a reminder, the atomic number represents the amount of protons. The electrons don't matter because they basically weigh nothing. The mass number minus the amount of electrons gives you the number of neutrons. So for carbon, you would have to subtract 6 from 12, meaning there are 6 neutrons in the nucleus. If you're unsure about the terms like atomic mass and molar mass, check out our videos to learn more. Keep in mind, the most important information within the periodic table is the element, the atomic number, and the mass number. Now, those are the most essential numbers in the periodic table. But what about the groups? Before we take a look at the groups in the periodic table, let's explain what the rows and columns mean. One row can be referred to as a period, This is why it's called the periodic table. 8 main group elements are located within every row. Row 1 is special because it only has 2 main group elements, hydrogen and helium. The period numbers represent the amount of shells in the atomic shell model. There is only 1 shell in the first row, 2 shells in the second row, and so on. If you don't remember the atomic shell model, then check out our video on this topic. Now, let's get to the columns. The columns indicate the main group we are in. The column number represents the amount of outer electrons, also known as valence electrons. So, the first column has 1 valence electron and the second column 2, and so on. Because they have the same amount of valence electrons, atoms of the same group react fairly similarly. Keep in mind, rows indicate the occupied shells and columns indicate the respective main group and number of valence electrons. Now, let's finally get into the groups. The most important groups are the 8 main groups. Each of the 8 main groups has its own name. The first main group consists of alkali metals and hydrogen. The second main group consists of alkaline earth metals. Groups 3 to 6 are described by their first upper element. Therefore, the third main group is called the boron group. Main group 4 is called the carbon group. And main group 5 is called the nitrogen group. Main group 6 is called the chalcogens group or the oxygen-sulfur group. Chalcogens means ore creator in Greek. The 7th main group is called halogens group and means mineral or salt creator because many salts consist of elements from this group. Main group 8 is called the noble gas group because they are all gases and they are too noble to react. These are the 8 main groups, guys, but there are also subgroups. These are named transition metals because every element there is a metal. You can also see the lanthanoids and actinoids group. These consist of rare earth metals except for actinium, because back in the old days, people believed that they only existed in rare materials. But in school, this group won't be of much interest. If your periodic table is more detailed, you can actually differ between aggregate states and substance groups. So, what do you have to remember? The most important information within the periodic system is the element, the atomic number, and the mass number. Elements are arranged by their atomic number within the periodic system. This number also indicates how many protons or electrons lie within an atom. The mass number indicates the atomic and molar mass. The rows represent the amount of shells and the columns the respective main group and amount of valence electrons. The most important groups are the 8 main groups, which consist of elements of the same grouping. There are also subgroups or, more specifically, transition metals and the lanthanoids and actinoids group. Well guys, that's it with the periodic table for now. But if you're up to learn more, feel free to click on the next video.